So, an exam style question. We've already kind of done a couple there, but here's a one for you to have a look at. A hospital records show that 82% of A&E patients are seen within 4 hours. 20 patients are treated in an A&E department. What's the probability that 16 of the patients are treated within 4 hours? So that's exactly 16. So as a bit of a hint here, we want the probability x equals 16. And the probability that more than 17 people are treated within 4 hours. More than 17 means probably x is larger than 17. Okay. Have a think about this one. It is very tricky. If you've just got into this, chances are you'll find this very difficult. Okay. You will need several hours on Binomial to get your head round all of it. But have a think about it. Remember those first steps. Work through the steps that we went through. Write down that distribution. You should have x is binomially distributed and try and fill that bit in. If you can get that done, that's good. Okay, that's a really good start. Get that done, and can you write the probability as well for each one? Then, next step, can you convert the probability to use a less than or equal to sign? If you can do that, you've made a really good start, okay? And I'll talk through how to do all the questions after you've had a go in a few seconds. Have a look at this one now. Okay, I'll run over this, the solutions to this question just so you can see how it's done. So, probability that 16 of the patients are treated within 4 hours. So we want, for this one, so I'm going to do, we've got x, and I'm going to say what x is. It's the number of patients treated within 4 hours, okay? You don't have to do this, but it can be useful to remind you of what x is. Number of patients treated within 4 hours. Oops. Okay. Now let's write down our distribution. X is distributed with a binomial distribution. What's our n? Well, there's 20 patients. So that's our n. What's our p? Well, it's that 82% of people are seen, so it's 0.82 there. Okay. Here's your n. Here's your p. Okay. Great. It's really good if you can get this written down. It really sets the context for the question and makes it a lot easier to answer everything. I really think it's worth writing down this distribution. Loads of people skip it, but loads of people get these questions wrong. So separate yourself from the crowd and write these distributions down. It'll probably pick you up a mark, to be honest. Now we think, what is the probability we actually want? Well, we said we want the probability that 16 of the patients are treated. So that's x equals 16. We then think, we've actually got an equal symbol here. We haven't got an inequality, so we don't need the cumulative formula. We just need to use the normal formula. So the probability of x equals 16 is, now if you remember the formula looks something like this. P to the x times 1 minus p to the n minus x. Now we've got n is 20, p is 0.82, and x is 16. So all we do is fill all that in. So we've got 20, 16 times 0.82 to the 16 times 0.18, that's 1 minus p, to the 20 minus 16. Okay, all I'm going to do now is put all that in the calculator. Remember that first bit, I'm going to use the C on the calculator, so I'm going to do 20, then the shift divide to give me the C symbol. 16, 0.82 to the power of 16 times 0.18 to the power of 20 minus 16, which is 4. And that gives us 0.2125. Normally we write 4 decimal places in these questions unless told otherwise. Okay, so 21% of patients, 21% of the time we'd see 16 of those 20 patients within 4 hours. Okay, let's move on to the next and more difficult one. So the probability that more than 17 patients are treated within 4 hours. So again, x is binomially distributed with n is 20 and p is 0.82. Just the same as last time, but now we want the probability that x is larger than 17. Now we need to think about how we convert that to use the less than or equal to sign. Well, we only want 18 patients, 19 patients, or 20 patients. Now, all of them, the probability of all of those possibilities must be 1. So we can write that as 1 minus the probability that x is less than or equal to 17. Okay, that's all the people from 0 all the way up to 17 that we don't want. We only want 18, 19, and 20, so we're going to subtract those people off. Okay, so that's that rewritten to use less than or equal to symbol. Can we use the tables? No, because p is 0.82 and that's not in the tables, unfortunately, so we need the formula. So it's going to look something like, so we're going to figure out the probability x is less than or equal to 17. The formula looks like this. Okay, it looks something like that. And remember, we've got n is 20, p is 0.82, and our x is 17 in this case. So we type all that in. So let's write that out. We've got r is 0 to 17. Then we've got n, which is 20 r. So that doesn't need filled in the r because that's, confusingly again, the r is the x in the calculator that we type in to do the summation. 0.82 to the r times, it's going to be 0.18, 1 minus p, to the 20 minus r. So I'm going to type all that in now. It's going to take a while. So remember, to get the summation symbol, it's shift then the log button if you've got the Casio FX991. If you've got a stats calculator, happy days for you. You can probably just give it n, p, and x, and it'll work it all out for you. And then inside the bracket, we're going to write 20 and then c, for combinations. And then on the calculator, instead of r, we type in x. So you press shift, close bracket. I'll just write that down to remind you. So that's x on the calculator. And it's shift, close bracket. Okay, to get that up. Times that by 0.82, and then shift x again. Every time we see r, we're actually going to write x. And then times 0.18 to the power 20 minus x. Okay. Type all that in and we'll get an answer. You'll find the calculator takes a long time to work these out. It's basically it's having to sum 18 things together. It's actually doing 18 different calculations. It's quite busy, so give it a moment. If it goes blank, it's not because it's turned off. It's thinking about it. That is 0.7252. And remember, if we come back to here, we said the probability x is larger than 17. We do 1 minus that. So we do 1 minus 0.7252, which gives us 0.2748. That's our answer. So they're probably the more than 17 people, or 18, what we mean by that is 18, 19, or 20 people are treated within 4 hours, is about 27%. And that's the answer for that one. And that's it. I think we've come in just under an hour there, luckily. So I know that was a long one. Thanks for staying with me. It is a tough section. Give yourself time to absorb all of that. Go through it a couple of times. Do plenty of practice questions. Get used to writing down the distributions. A really important part of it. If you can write down the distribution and write down the probability that you want, you've done most of the hard work. It's really just typing numbers into a formula after that. Next time, we're going to apply the stuff we've learned by looking at hypothesis testing. Hypothesis testing is quite interesting. It's about whether something's happened by chance or whether it's actually because the probability we think it isn't right. It's quite an interesting section, and we'll be using the binomial distribution there. Loads of practice questions, hopefully some additional videos coming on the binomial distribution as well on the Solve4x website. So go on there, if you just navigate to the statistics into the binomial distribution, you will see loads of quiz questions and problem papers and summary sheets, all sorts of things to have a look at, which will hopefully help out a lot. And hopefully coming, there will be some additional videos to show you how to type in those formulas. So thanks very much for watching this one and staying with me. I'll see you again next time.